With all the hype about DeepSeek and disruption in the global markets, is there any practical takeaways? Might there be any practical takeaways for practitioners in data science and engineering and machine learning to glean from this? And in fact, there is. There is a practical takeaway from the DeepSeek disruption. If we remove all the geopolitical sort of drama and the privacy issues and abstract all of that away, there is a core practitioner takeaway here that we can get into. But before we get into specifically that takeaway, let's do a little history lesson about deep learning. So to understand where deep learning is right now, we need to break it out into the two prevailing camps in deep learning, and that's basically your connectionist view. And the connectionist view of deep learning is essentially everything can be learned from observation. And this is based off of the empiricist theories or the radical empiricism of the mid-20th century. So this was the theory that everything humans learn is through their observation, through observing. The second camp is entirely opposed to this connectionist camp, and this is the symbolist camp. And the symbolist camp says it's actually the opposite. It's humans don't fundamentally learn through empirical observation alone, that there's certain templates, there's certain rules that are embedded in us from birth. And one of the arguments they use is language and how young children, 2 and 3 years old, can understand the complexity and the recursivity and the infinitude of language from the start. And no matter where the child is born, no matter what their environment is, they all seem to be born with these templates. So this is the symbolist view of deep learning, or at least the implications of deep learning and whether or not we can obtain some type of abductive or transductive reasoning through these models, which is the way humans learn, or the way humans sort of inference the best explanation. Let's say humans generally are very good at making decisions or solving problems with elements of uncertainty and reducing that uncertainty without any actual direct evidence. That's through the process of abduction or transduction, where they're composing bits and pieces of knowledge together to come up with an inference to the best explanation. And humans do this very, very well. Machines do not do this very, very well. And the idea is to get machines to do this very, very well, you have these two viewpoints or theories on how to get there. One is the connectionist view, and the other is this sort of symbolist view. And then there's a third, which is a hybridization of both, which is a lot of the industry is moving in this way of experimenting with hybridization of both connectionist solutions and symbolist solutions or implementations. So what does this mean right now? Most of the commercialized products, most of the companies with commodity foundational models are in the connectionist camp. In other words, it's more data, better data, synthetic data, add big compute into the data, and from this will emerge the ability to abductively reason or transductively reason. And this is the scale is all you need camp. Most commodity foundational models are in this camp. I could be wrong, it might not be precisely all in this camp, but publicly, generally, when you hear them speak, it sounds a lot like the scale is all you need camp. And this is precisely why NVIDIA stock went through the roof. Because if your theory is the connectionist view based in this radical empirism of the mid-20th, then scale is all you need. We get more data, we get more compute, and eventually abductive reasoning will emerge from this process. So what did DeepSeek do? Did DeepSeek have a connectionist breakthrough, or did they have a symbolist breakthrough? Where did the breakthrough come from? Which camp? Or was it a hybrid? Or maybe it was a hybrid breakthrough. Well, it turns out it was neither. The breakthrough that DeepSeek did was simply good old-fashioned engineering. This was good old-fashioned engineering first principles that was able to increase the utility of the output and decreased the cost of the implementation. So efficiency in both ways. And this is the takeaway. The takeaway for technology departments and engineering teams and architects is do not underestimate the transformative and innovative power of engineering first principles in your current system. And this gets to a thought experiment where to try to drive this type of innovation, this type of first principle innovation, is think about your current systems right now. eliminate any ability to vertically scale them, to throw any new money at them. All you have is your current systems. Now imagine you need to make those systems support X or 10X, X growth. Imagine how, if you had no money, no ability to vertically scale, can you engineer your way through this to support X, 10X, X, whatever X growth? And through that thought experiment, new novel applications of fundamental engineering principles will emerge and new ways to innovate without spending a single dollar or scaling to a single server. And this is the takeaway. The DeepSeek innovation was simply fundamental engineering, and it lends us to consider, with all the money and all the hyperscaling and all the cloud servers and all the vertical scaling that we're doing and all the money that we're throwing into cloud computing, spend a little time rethinking your designs, rethinking your current systems, and are there other innovative ways to move through the system more efficiently in its cost and in its utility of its output without spending another dollar. So that is the takeaway, the practitioner takeaway from the DeepSeek Disruption.
For Robbie Innovations.